All right. Hello again, everybody. Welcome back. You have just some things to do in section 5.3. We're going to do examples of that. And then section 5.4 is right triangle trigonometry. We're going to get to that in this particular video. But first, this is an important topic. Using reference angles. Reference. And so we finished the last tape with this, angles. Using reference angles. Reference angles. And if you recall, here's a coordinate plane. In the first quadrant, the reference angle is just theta. In the second quadrant, the reference angle, you obtain a reference angle by taking 180 degrees minus theta. Or in radians, pi minus theta. In the third quadrant, you would go all the way to theta and then subtract 180 degrees. Reference angle theta minus 180, or theta minus pi. And in the fourth quadrant, well, here you have to go all the way to 360 and then back, so you'd take 360 minus theta is a reference angle, or 2 pi. And so that's in each quadrant, and then further it gets, in here, a point here, the x is going to be positive, the y is going to be positive as well. A point over in the second quadrant, the x is going to be negative, the y is going to be positive. The third quadrant, a point, they're both negative, and the fourth quadrant, a point, let's see, the x is positive, and the y is negative. And all that is meaningful because here, all 6 trig functions are positive. Here in the second quadrant, in quadrant 2, because the y is positive, the sine is positive. In the third quadrant, because the y and the x are both negative, and tangent is defined as y divided by x, and negative over negative, tangent can be positive. In the fourth quadrant, because cosine is defined as x, the cosine here is positive. So here's mnemonic devices. All scholars take calculus. It's one way to remember it. Meaning all 6 trig functions are here. Here it's the sine, and because of reciprocal identities, it's also the cosecant. Those 2 are positive, the other 4 are negative. Here it's the tangent, which is positive, and because of reciprocal identities, the cotangent. The other 4 are negative. The cosine and the secant. The other 4, again, are negative. All 6 positive, 2 positives and 4 negatives, 2 positive and 4 negatives, 2 positives and 4 negatives. You can derive that just because just look at the coordinate plane and the positives and negatives. So how do you use that? Well, here's a question. Cosine of theta is 5/13. Theta is in quadrant, well, let's see, first off, it has to be in this one and this one, the first or the fourth, because cosine is positive. So we'll call it quadrant 4. What are the others? What are all the trig functions? Other 5 trig functions. What are all 6 trig functions? I would suggest you make a table something like this. When we ask this question, which is going to be over and over and over again, sine, cosine, tangent. Then I always put cosecant here, secant, and cotangent. These are reciprocal identities, or we're just going to find something for tangent, and we're just going to flip it for cotangent for all 3 of these. They're reciprocals. So now what are the other 5? Here's where we have to go. The cosine is 5/13, and we have a Pythagorean theorem. Cosine is 5/13. Sine squared plus 5/13 squared is 1. 25 169. Subtract from 5, 12, 13. Right, it's 100. So sine squared is actually 144. 169 or sine is plus and minus 12/13. Now, it's plus or minus. We don't know. Well, we do know because right here, it's in quadrant 4. Sine is negative because the only positive is cosine over here. So then it's negative 12/13. Might as well just go straight across. Negative 13/12. Cosine is given. Secant is upside down. Tangent. Sine over cosine would do it. 12/13 over 5/13 is 12/5, and notice it's negative 12/5. Because over a couple of reasons, because it's this one over this one, and that makes it negative. It's also negative because it's in this quadrant. Tangent is only positive here in the first one. And then the cotangent is going to flip this. Negative 5. Whoops. Yeah, negative 5/12. Okay, that's an example. Let's just do an. Yeah, that's an example. Let's just do another one because I haven't done. And I just made a Pythagorean triplet. And this, I'm just making one up. It's not going to be a Pythagorean triplet. Say, give us like cosecant theta is 10/7. So cosecant is positive. That's this quadrant right here, or the first one, but we'll say quadrant 2. What are the others? Table like that. So the first thing is cosecant is this is 1 over the sine. Cosecant is and sine are reciprocals, so it implies that the sine is 7/10. Sine of theta is 7/10. And there you go. Now it's a problem like what's on the other board. 7/10 squared plus cosine squared is 1. Cosine squared is 51. Square root of 51/10. Cosine is the square root is plus and minus square root of 51/10. Because it's in quadrant 2, it's negative. So we're going to do a list like this. I'll just erase this board. Sine, we already have, is, let's see, 7/10. Cosecant is what was given, 10/7. Cosine theta, that's what we just figured out, square root of 51/10. It's negative. Because of this information, it's in quadrant 2. And then we just flip that for secant. Would be 10. We just leave it as 10 over the square root of 51. You can rationalize that if you want, but you're going to have a calculator. So, you leave it there as far as I'm concerned. And then tangent of theta, this one over this one. 7 over the square root of 51, but it's in the second quadrant. That's got to be negative. Cotangent. Flip it. Something that looks like that. We're going to ask you to do problems like that pretty much over and over again. Let's just do some identity. Let's turn the page here and do some identities. No, I'm sorry. Let's stop. Boom. I should